Hello everyone. This video is half about scratch building a tracked vehicle and half about how to misuse servos. This is the tracked vehicle in question. It's my second attempt. I can't show you the first attempt. It's in pieces. I'm going to start with the chassis. So it's made out of like brass. It's like brass box section. And brass plates. You can see the bottom of the chassis is just one big brass plate, and then it's soldered together at all these points. You can see my terrible soldering work there. The solder I've used is what's called metalwork solder, so that's some normal electrical, like circuit board solder wire. This is metalwork solder. You can see it's a lot thicker. It has a higher melting point, so your normal soldering iron probably won't do it. I use a small blowtorch. It's a bit tricky, you know, you got to kind of just guess the temperature you're heating the parts up to before applying it, but it's not too difficult to get the hang of, and it works. It's much stronger than normal solder, so it works for this application. Not as strong as brazing or welding, obviously, but it's enough. I've also used just some bending techniques here. You see, to get these sort of angled sections on the box. What I've done is you get a straight piece, make a small cut with a cutting wheel on a Dremel, bend the piece, and then solder it up. So that's how you get those nice angle bends there. Probably the only other tip here is I made some mistakes early on with the soldering where, like mainly through impatience, once I was soldering something, because I'm using a blowtorch, everything is very hot and you have to wait for it to cool down, so I was cooling it down with water or some other liquid. When you quickly cool down brass, it becomes brittle, like it's hardened, but it becomes brittle and it's more inclined to break, like to crack. So I would recommend, if you're doing that sort of soldering, just let things cool down slowly, and then it stays sort of soft and supple and is ultimately better because it won't crack. Let's go on to the drive. You can see it's driven by these sprockets, and inside the track here you can see it's plastic chain with bits of rubber glued over the top of it. So the plastic sprockets and the plastic chain I just bought off the internet. This is one of the tracks. You can see it's actually 2 rows of chain. On the first attempt here, I had just a single row of chain with the same, glue the rubber on technique. It was always derailing, so having 2 rows of chain is much better. It really prevents most of your derailing, so that's probably the first big mistake that I tried to fix on this. You might notice that, so these are the plastic sprockets that I bought, but these ones here don't look the same. So the kit didn't come with sprockets that were very big. The first attempt at this used these sprockets as the drive sprockets, but because they're so small and the drive system I'm using, which I'll explain in a moment, is really very slow, so it made just an incredibly slow tracked vehicle. It was snail's pace stuff, so I wanted to make much bigger drive sprockets to get a gearing up effect, and make it just the whole thing go a bit faster. It's still not very fast, but that's what I did. But in order to make these, because it didn't come with those, so I had to make them by hand. I had to it was really difficult. I spent 2 days doing a bunch of maths that I didn't really understand, and in the end I think it was probably just luck. They're actually made out of polyester resin, so I made one, and then I made a mold out of plaster of Paris, and then I made 4 of them, 2 on that side and 2 on that side, out of polyester resin. Once they're finished, they really work quite well, but they were difficult to make. If I was going to ever attempt to do this again, I would definitely make friends with someone who had a 3D printer. I'm sure that would be much easier. You might also notice this kind of like bogey structure here. it's like the running wheels or the road wheels on a tank. The main reason for that is to keep sticks out. So on my first attempt, it didn't have anything there. It's just a big gap here. And what would happen is sticks would fall in to the tracks. They get dragged into the sprocket, and that would cause derailing. So I'll just briefly show you how it runs. So that is actually full speed. So you can see it's really not a very fast vehicle. And I'll explain why that is now. Let me just open it up. So this whole part hinges forward, and there's the inside. What you've probably noticed is that there's no motors, no speed controllers, at least not in the traditional sense. I have used servos to perform that task. So this is about servo modification, or really servo misuse. I'm not going to call it a hack, because I'm not sure this is actually a good idea. It's just a thing that you can do. So I've modified those servos for continuous running. The way you do that is, so here's just a regular servo. When you open this up, which I'll do carefully, when you open it up, so this is where the arm goes on. If I take that gear off, some difficulty, what you can see in there is this little brass tab that turns around. That is the tab connected to what they call a potentiometer. A potentiometer is a variable resistor, and that is the thing that tells the servo circuit board where the servo arm is in relation to where it should be, or where you want it to be. So that's the key part. In order to modify a servo, what you do is you cut that off. You get your Dremel cutting wheel and you cut off that part of the servo. So I'll show you a modified one. There it is. You can see that metal tab has just been cut off, so it no longer sticks out. What that means is that the servo just keeps running in any direction according to how you've, according to the stick on your transmitter. It performs like a speed controller function as well, because if you pull the stick a little bit, it'll move slowly. If you pull it a lot, it'll go at full speed. I'm not saying this is a good idea. It's just a thing that you can do to a servo. The advantages of doing this are really just that, where you would usually need to have, as I said, a speed controller and a motor and a gearbox to lower the gearing on the thing for an application like this. Modifying a servo, you get all that speed controller, motor and transmission, the gearbox, all in one nice neat little box. That's great. The disadvantages are that servos are geared really low, so you're never going to do anything quickly with this. It's always going to be very slow. There's also a neutral issue. So when you do this modification, you cut that off. You cut off that little tab leading to the potentiometer, and then you plug the servo in, get everything turned on, get your transmitter set to neutral, get all your trims set to neutral, and then you get a pair of tweezers and you turn that potentiometer around until it's at the 0 point, the neutral point, and everything stops running. And then you put a drop of super glue in to hold it in that place. And then forever after, your neutral stick should be servo being still. It doesn't actually work that way in practice. Like this, the 0 point, the neutral point on the servo, it actually drifts around a little bit. So you will forever be just adjusting your trim a little bit to get it to stay still. And it drifts in both directions too. So, if you want it to actually sit still in a reliable way, this is not for you. It just won't do that. It will always just drift a little bit. The other disadvantage is this process is not really reversible, so only use a really cheap servo that you don't mind throwing away, because once you've done this, that's it. It's only a continuous servo. The other thing I would say is I've only ever done this to analog servos. I know nothing about digital servos. I don't even know what they look like inside or whether this would work, and they're probably too expensive anyway. Don't do it. So that's it. That's scratch building a fairly simple tracked vehicle and misusing a servo. I hope you learn from my mistakes.